never gonna get over that intro music. It's it's so dramatic.
Yeah, dramatic lovey. Get ready for our keynote or something.
It's also, if I feel like the music makes me think I should be like, welcome everyone, we are back. You've got David and Josh here. We're gonna take you through some Rainlang today. So what's on your mind today, David?
Yeah, I'm not really prepared for that. That level of energy.
But even like,
I'm in like a hoodie with a cup of tea. I'm not ready for that.
Even the bankless guys, they get pretty hype.
Yeah, but that's the whole thing, isn't it?
We're not really presenters, I guess.
No. No. After we've been like grueling our day through code, we're ready to chill with a cup of tea, not hype the latest protocols.
Should we wait a minute and see if anyone jumps on? We've got one person. I think it might be Toby. Is that you, Toby?
You can't tell who's who in the chat, can you?
No, everyone's just anonymous.
Just anon.
Yeah.
Cool. Yeah. Well, I mean, in chat today we've been talking about this clearer lock idea, which is pretty cool. So we could probably talk about that a bit, because not everybody is sitting in our Telegram group and reading every single message. It's a cool idea. Yeah. So basically, we had this idea already of the sampler. Actually, are we waiting for more people to join, or should we just get into it?
I think let's just get into it.
Just get into it. Yeah.
Yeah.
So we already chatted about this sampler last week, I think it was. It's 2 or 3 sessions ago. So it's a pretty widely applicable pattern where basically you don't ask for any input tokens. So you just set it to 0 for the IO ratio, and you set an amount of tokens that you're offering. And then that basically becomes a gas budget for someone to come and run your strategy. And the strategy won't give you any tokens. It'll just give up some tokens. And then inside the strategy, you can make some state changes. So you can, it's called a sampler. So you could, the original example that we used was you could sample an oracle, for example, which could be, I mean, you say oracle, but in this case, it could just be like Uniswap prices or something. So you could make a private oracle to your strategy that is a reflection of an external oracle, something else on chain, and then save the data, as much data as you want, and you've got total control over it. So if you've worked with Uniswap and you know much about it, they have like a TWAP, which is sort of this idea, except you have no control over how much data is retained by Uniswap. They keep like a fixed number of trades, and every trade updates it. So if there's a lot of trading going on, they'll exhaust the amount that they store in the TWAP. And if it's relatively quiet, then it'll last longer. So it's time-weighted average price over an unknown period of time. But if you have your own oracle, you can, or if you have your own sampler, you can keep the data around as long as you want, basically. Like you can set your own data retention policies. So that's cool. We went over that. And then today in Telegram, we were chatting a bit about a bit of a twist on that idea, where the thing that you sample is it could either be the counterparty to the order, or it could be the clearer of the order. So who's the person who's actually calling the function. And the idea there is that you could lock the strategy. You could set up some kind of system where someone comes along and says, look, I'm going to fill the order. And then they call the order, and then the order actually records who sort of reserved it for themselves, locked the strategy, and then they can go and do something, and then they can come back later and fill the strategy. So why would you want to let somebody exclusively lock your strategy? Well, they might need some time to go and get the liquidity to trade it. Maybe it's on another chain. So this whole thing came up in the context of cross-chain swapping, saying how can we do cross-chain stuff on Rain? And the idea here is like you could see you're on one chain and you see an order and you see a better price on a different chain. So you could basically call the function, lock in the price for yourself in the Rain strategy, go to the other chain, do something, get the better price, and then come back, bridge it or whatever you want to do, and then finalize that order that's been locked for you. So kind of ran around on how that could be possible. And then, yeah, we came up with this, like a novel pattern based on an existing pattern, really, where you sample the counterparty or the clearer on the first call, and then the thing that's reading from the sampler can see who it's locked for. And then you have some condition, maybe it expires after a few minutes, or maybe something else happens. There's some other condition where you can release the lock by basically deleting the sample. You delete who was recorded as whoever has got that lock. And then, yeah, we talked about it a bit more, thinking, so there's one thing that's missing in Rain that would make it really neat, is if you could do like an inverse bounty and make it so people can have to actually pay to acquire the lock, because you obviously don't want your orders locked for no reason. So you could basically say, okay, the locker is going to pay the lockee for the right to have exclusive access to that order for a certain period of time, or whatever it is. And then even if the order is not clearing, the owner of the order is getting like a bit of income for the inconvenience of their order not clearing. So yeah, it was a cool conversation. We came up with like a bit of a workaround for you not being able to do that directly, where you could basically set a really high IO ratio. Like, for example, you could say, I'll accept 2 DAI for $1, or 1 tether, I guess, right? So then you make a profit of $1, and then that could be a lock fee. It's like a workaround until we make it natively supported.
Yeah, I mean, I've always just thought of this idea like options. You're buying the right to execute at a specific price at a time in the future. So like as the placer, I'm just selling off an option. And I wonder actually if you could, the cool thing is that the order placer gets to decide on the terms. So you could decide what price the option is, and you could decide how long the option's for. Would be interesting to explore whether you could have it so that the buyer of the option can choose how long they want to buy it for, and they can buy it for longer or shorter amount of time, depending on the risk that they want to take on and how likely it is they think that they're going to be able to get that price within the time limit. But what's cool about it is that it becomes a market. So it's just a market of people selling off exclusivity and people wanting to buy. So if a user sets their exclusivity fee too high, if they make the options too high and it's not competitive, then the fillers won't pick it up. They'll just say, well, that's too expensive. I'm not willing to pay you that much on the off chance that I can't complete this round trip and give back to you. But at the same time, the filler could decide, well, in the off chance that I can't do it, I can also have my own capital on hand and I can make the swap myself. So at least I get your tokens, even if it means I'm now drawn down on something I maybe wasn't wanting to be drawn down on. Because it might be better to do the swap out of your own pocket if you miss the time limit. And then at least you have the other side of the trade versus just losing the option fee altogether.
Yeah. I feel like this is a thing that people like they like options. I was going to buy an option the other day. I'm glad I didn't. I'm glad the interface bugged out and stopped me from doing it, because when the ETF announcement was happening, I was like, oh, for sure, the market is going to move in some direction after this whole ETF thing happens. Didn't move at all.
Yeah, I know, that's crazy. But okay, so that's interesting, because then you could actually have someone could build. You've got this idea where it opens up cross-chain swaps, which is how we thought of it originally. Actually, we were talking to, if you remember, it came up because we were talking to Harry from Oasis at ETH Denver.
Yeah, I remember. Yeah, that was like the cross-chain idea originally.
Yeah, because he's really been trying.
I think the conversation today was a little more concrete. Like, how could you actually, like, that's a cool idea from like a game theory perspective. But the conversation today was like, okay, can you actually write a strategy in Rainlang that encompasses all of this? And the answer seems to be yes. A little bit hacky, but yes, which is really cool. And also, if we made some really minor tweaks to Raindex, so that you could support like a negative bounty, for example. So you could say, I want to be paid for the strategy to execute. Like a few little tweaks like that, and it would actually be like quite a clean solution.
Isn't the IO ratio though? Isn't it a minimum IO ratio anyway? Can you overpay me? No.
It's exact. It's always exact.
Yeah, you can't overpay. Okay, so it's a maximum output from my order, but it's a exact ratio that I'll ever get paid. You can't overpay me.
No. I think basically we need negative numbers, and then if you set a negative IO ratio, it means it's an OI ratio, like an output, right?
Yeah, because otherwise
it would go back in the other direction somehow.
Because I over O, if you want O, the amount you're paying to be 0, then no matter what you're asking for in return, the ratio would be divided by 0. So you can't have that. But you could do what I said this morning, which is to have an extremely small O.
That's the workaround. Is basically you make a really, really bad price on a very small amount, and then you will send them some dust, and then they will send you the actual fee, which is the right to lock the thing. So say it was on ETH. I mean, ETH's pretty expensive. So it was an Arbitrum. So you're spending ETH. Everybody knows ETH. So you could say, all right, I'll give you like a tiny little bit of ETH, like one way, and then you'll pay me $5 for that one way, which is an extremely bad price, because one way is 18 decimal places.
By the way,
and then that will be your hacky workaround.
By the way, there's someone here.
Yeah.
Whose username is oxsolver.eth. oxsolver. I'm assuming.
We like solvers.
I was like, name checks out.
Yeah, totally.
So interestingly, the thing about this is, although you can easily, well, not easily, but fairly trivially, you can program in. Oh, hey, it's Barath. Hey man. So the interesting thing is to think about what it means for a solver, because a solver then has to be able to see that this exists. So like somehow the solvers will have to be smart enough to either, there's two ways I think about this. One is, the simple way is someone makes an app where you can do this. Like someone just builds an app on top of Raindex that's a GUI that they come up with where people can do these kinds of trades, and then they run their own solvers and point them at the orders, and then because they are part of the conveyor belt of creating the orders, they also know which ones to look out for, and they can spot them. So that would be easy. Or more abstracted would be like a wrapper, like we've talked about, like a wrapper that can inject things into the strats. So you could have your regular strat, but you could, on the way, you pass it through a wrapper, which injects a standard options seller into it. So then any solver that's pointing their bot at orders that are being passed through that wrapper know again that there's going to be a standard thing on the other side of it that they can interact with.
Oh, it doesn't even have to be that. The reason I like the wrapper approach with, you mean with like the factory and it like injects the extra bytecode and everything?
Yeah.
Yeah. The reason I like the wrapper is that if you design the wrapper well, so that you could basically, in this example, we can design the wrapper well, I believe. You could say literally any strategy, I don't even care what it is, plus this extra check fits a pattern that you could do like static analysis, and you could actually look at the bytecode and say, oh yeah, I see that that check is there. And then you could reliably scan the code and actually see that that check exists and understand what that check is supposed to mean. So you could actually create, in theory, like an automated thing. So if you're doing the solving, you want to know what logic you need to write to do the solving, right? Like you need some kind of reliable way to identify that, oh, that order is that one's a Dutch auction, that one is like an option, that one is a dollar cost average, right? Like you need to like categorize these things so you know how they're going to behave. And
possibly,
I mean, if you wanted to go like, if you were doing like risk analysis on it, right, you might want to know.
Yeah. Well, I don't know. Would you do categories, or would you? I mean, there just seems to be different. I mean, ultimately, you want some sort of. It's like a chess game. You want to be able to like calculate all moves. So you want to like be able to look at a strat and see what you can do to influence it, and all the possible states it could move through and what they would mean.
Well, this is why today one of the questions was, can people withdraw the order? So the order could be locked, but then the owner could pull the order out of the order book itself, and that would implicitly make the lock useless because the order's gone. So this is the risk analysis, which is like there's a cost to actually simulate the order over and over again. So an order which is just really simply evaluating to some numbers is going to be pretty cheap and pretty safe. And then if you did like a crazy complicated thing that's relying on external Oracle prices and all of this stuff, then it's going to be more to evaluate. I mean, these are small things, but if you add them up over many orders and over a long period of time, it would make a difference to your solving infrastructure. Like if you're trying to maximize profits, you want the thing that is the cheapest to simulate and the most profitable at the same time. And then
and the most predictable.
Right, because the other risk is like, okay, now I've done the discoverability bit and I've found something that I think is successful. Now I have to actually submit it, and lots of things can go wrong between discovery and finalization. Like it could be front run, the order conditions could just change, like all kinds of things can happen while the order is still being submitted. So there's sort of like two, I mean, when I've done the write-ups on this, because we're going through the same process, so there's sort of like two headings. There's like the discovery phase and the like delivery or submission phase, and both of those have their own risks. So the more assurances you can get as the solver, the better because basically what's going to happen, like if we look at this like an insurance company would, it's all statistical, right? Like a high risk order, you could be like, sure, I'll clear it. It's a high risk order, but I want a bigger bounty. And that basically translates to a worse price for the user. So in theory, if we were like perfectly mature, perfectly sophisticated, it would all be figured out and users will just get a better price if they bake in more assurances for the solver, right?
Yeah. Well, yeah, I can also see, this is like a far off point, but I can also see a world where kind of like the way Flashbots works for RPCs and like trades that get placed through RPCs, I can see like solvers banding together and saying to people, make us the set of counterparties that can use your order, and in return we'll make sure that whenever you get preferred execution, we'll take on bigger risks, we'll work with more exotic order types, all these kinds of things.
That's true, because the order owner can actually do that, which I think is interesting. Like they can, we did this actually with a project. They wanted to put the order up and they also wanted to run the infrastructure for various reasons. Doesn't matter. But you can do this basically. So you can make front running impossible for the clear of the solver if you do that, which is really cool. So basically, if you're the solver, maybe you could register with some contract, and then you're like a certified solver, and then the order owner can say, all right, the counterparty has to be a certified solver, and they put their owner up, and then those certified solvers know that they can submit transactions, and they can front run each other, I guess, but at least they can't. It's not like Flashbot situation where someone's scanning the mempool and then they see the profitable transaction and then they resubmit it with like one more gwei on the gas, and then they get slightly in front, and then they get everything, and you, the solver that actually found the opportunity in the first place, get negative. You have to pay the gas for your execution reverting, and you don't get any profit from it. So you've like done all the work and you've been punished for it, which is the bad state of affairs, which is the default.
And of course those solvers they can figure out however they want to coordinate also, because the counterparty could still be a single address. It doesn't have to even be a set. They could share an entry point.
Oh yeah, if you could do it for a group of people, you can do it for a single person. That's an easier thing to do. Yeah. So you could have a direct relationship with the solvers potentially, and get like better. I mean, here we go. Someone can go build this. Go build this on Raindex. Someone out there. Make a thing where you make a bunch of solvers. It's basically like, is it like Flashbots? No, it's like the international consortium of friendly solvers.
Well, no, it's like it already. I mean, this is the way other intense protocols already work, right? So like, CowSwap has a bunch of solvers who have been brought on board, and they do a secret auction off chain. Yeah.
But they're tightly coupled the expressivity of intent, who can do the solving.
Yeah, exactly.
What the bounties and the profit motives are.
Yeah.
All the contracts are so they've taken like a whole bunch of things and then they've like lumped them all together. So,
it's an opinionated stack.
Yeah. So we basically.
You could build.
You could do the same thing. You could build a CowSwap basically if you want, out of all the individual parts, if you wanted to.
Exactly. You could build CowSwap, and you could even make it secret. You could even make the order secret, because you could pass your Rainlang order directly to the solvers. If you decided that you trust them and you're happy for them to do it, then you could sign the expressions, sign your orders, and send them secretly to them, and they could do whatever they need to do, and then fill them and never reveal. I mean, although I guess it would be visible. Would it be visible in the node logs? Is call data visible in node logs?
This is what Oasis Sapphire is for.
Yeah,
we've come a full circle. This is how we started talking about all of this, like back in Denver, was specifically because we were talking about cross-chain swaps and confidential trading and how to solve it.
Yeah.
So that's basically how it comes back to it.
Brad said, I assume you're talking about CowSwap. He said they're doing amazing. Now they've moved to an L2. Yeah, I mean, CowSwap, I think CowSwap seem to have the first movers advantage in terms of the intense side of things. It is interesting. I mean, I think it'd be interesting to think, well, what is it that people love about CowSwap? I'd say it's probably the convenience and maybe the gas.
Probably just simple and easy to use.
Yeah. Someone said, for market orders, I think one methodology is to quote below the Uniswap pool, and you were always clear. Could you see a way it could work on strats inside Raindex? Yeah, that's if you look at example strategies, we're not using the Uniswap pool quote. We're using the FTSO oracles, but that's exactly how the examples work. They I mean, we can bring one up right now because I think
And we have done it with the Uniswap pools in the past. I'm not sure if we've got it in the pub strats. I think we just did that. I think we just like wrote some strategies that do that and put them up at some point.
Yeah, I'll show the example and then we can talk about like what does it even mean to be getting a market price.
Yeah, and this is probably how the liquidations would work actually in the lending protocol when we set that up.
Oh, I hear you. Yeah, cool. We're gonna bring it up. Yeah, so this is one of the pub strats. Actually, you know what? I won't do it here. I'll put it into Raindex.
Yeah, use the app.
Because it looks nice as well. Cool.
Yeah, you'll know we've made it when GitHub supports native syntax highlighting for rain files.
That'd be awesome. So this is one of the example strategies. It's on the docs as well. So this one is it's intended to be the simplest possible order. I don't know if that's totally true, but it's pretty damn simple. It gets a price from the FTSO, which is an oracle, and then it adjusts it by multiplying it by 90.99. And then the output amount is 10. So that's an arbitrary amount. And the IO ratio, or the price, is the adjusted price. So I got the market price, but I'm actually offering a slightly worse price, a 1% worse price. And the idea is that that's creating a bounty or like an incentive between the market and what I'm offering, and that is for the solver, basically, to pick up, and then that's for them.
So if you swap the FTSO out for a Uniswap the other one, the exact output word, then it'll include slippage, it'll include fees. And what's really cool about this, if you were around in the last bull and you got used to spending $500 for a swap when the network was congested, and even with that amount of gas, you still had a pretty low chance of actually getting a swap to clear because it was just so congested and there was so much competition for the mempool. If you were going to do this off-chain and you were running a bot and the bot tried to do the same thing and was like, oh, okay, I see Uniswap is at this price. I'll submit an order which is 1% below Uniswap. And then you submit it when the congestion's high. A Uniswap price can, especially if the market's dumping, the Uniswap price can dump past what you submitted in the time it takes you to actually submit the transaction because the network's congested, right? So doing it this way looks like the same thing, but it's actually way better because it's getting the Uniswap price in line with the order clearing. So you submit the transaction, and even if 5 minutes passes between when you submit the transaction and it actually goes through, it doesn't matter because it's going to get the Uniswap price as the transaction's clearing, and that is going to be the price. So the bounty remains for the solver no matter what the market conditions are, if that makes sense.
Yeah. So Brasset is not slippage. It's not, the adjustment here isn't slippage, no. This isn't slippage. The order always gets exactly what it asks for. So you're not saying I want the FTSO price and I'll take anywhere down to 99% of the price. You're saying my offer is exactly 99% of the Oracle price, always. So it's a fixed amount below. If you want to
1% goes to the solver.
Yeah, exactly. If you're like, oh, well, what if I don't have to give them a whole 1%? What if they would have been happy to take it for 0.5%? That's a question you might ask. Well, then you get into the idea of, like we've explored loads, is the idea of auctions. So you might start when your order deploys, say you want it to clear ASAP, you deploy it, you say, well, as soon as I deploy it, it's going to offer exactly the Oracle price, which, by the way, might still be a profitable art because the bot may be able to find a price on chain, which is already better than the Oracle price, in which case, cool, that's fine, because the Oracle is an aggregate of a bunch of prices from a bunch of different places. But imagine it's not, then yeah, it offers the FTSO price, the Oracle price when you first deploy it, and then the price slowly dips away, and then you're doing an auction. And in this case, you're auctioning away from the Oracle, so you're increasing the bounty between the Oracle price and whatever Solver's willing to pick up. And obviously, if you let that auction go forever, it goes to zero. And if no solver, if for some reason the solver's asleep and they miss your order, they might only see it when you're already offering 50% of the Oracle price.
This is the real reason why we need more solvers. The more solvers, the better. We never want to have a gap in coverage when people are doing auctions and things. We want
so this is why
just a bit of redundancy. If one of them like has an internet outage or something, you want another one running.
Brad asked, how long have you guys been working on this? The oldest contract deployment goes a couple of years back. How did this idea come around to create a Lang altogether? It's been a long journey. We didn't start off trying to create a language. We actually wanted to make smart contracts more configurable. And I think there was more and more business requirements from a project we're working on to create more and more configurability. And then Dave realized that he should just create a mini interpreter that you could string together a bunch of arguments. And we wanted it was actually for membership gating. So we wanted if you've got this membership and this membership, or this membership and this membership, or this membership and this membership, and if you have this NFT balance, then you can get access to this thing. So
very logical, yeah.
So it was more about having infinitely configurable logical gates for access, and to the protocol we're working on. And then I think, one day you were like, I should just make a mini interpreter. And then me and Dave, the other co-founder of Rain, laughed. And then I think you came back later that night and you were like, here's the first draft. And then you realize, okay, we have a logical gate. That's cool. We can string together logic. But what if we want to pass information between the stages in the logic? So we need some sort of way to pass it, to keep it, hold information in memory as we go through this logic. Oh, we need a stack. And then for a while it was a stack. It had a memory, but it basically had no storage. You couldn't store anything between different executions. And then one day we were like, oh, we should add set and get. So we should just add some simple sandbox storage to this thing. And there was no language, still no language. It was just opcodes. So we would literally write in raw opcodes.
In JavaScript with enums. The whole bit where you write these strings and then it actually goes into a contract and gets repassed. That is much newer than the bit where we have the mechanics of dealing with the stack and dispatching logic and everything. If you go and look at the Sushi router, they have a really rudimentary interpreter. I guess it's an interpreter, that does routing. When you get the route and then you submit it to the Sushi router, it goes through and it mechanically goes, oh, I need to swap this token and this token on Uniswap v3. Then I need to go to Uniswap v2. Then I need to do this, and it loops over it.
It's a string of bytes that basically contain all the instructions of all the swaps it needs to make along the route.
Yeah, so you can actually find other examples of things like the interpreter bit in the wild, but as far as I know, this one is the Rain one has the most words and it's probably got is the most full featured in terms of trying to be more general, and it's the only one that I know that actually also has the string passing on chain as well as the running. The Sushi router one, there's an off-chain library that builds the route for you and then you submit the route, which is what we used to do. At the start we were basically doing the same thing. There was a JavaScript library that would create the bytecode for you and then you would submit the bytecode, and then we moved all of that on chain. So that's where we're at the moment.
Yeah, and then I think at some point you had the idea to, because we were using Rainlang for other things first, actually. Oh yeah, so CalSwap followed something similar, but solvers send the route. Yeah, that makes sense. It's basically just saying, it's like when you've got configuration or like parameters for a function, and you want it to be like, what's the right word? It's like when you can't create, because like it's like the permutations of the parameters go beyond what you could put inside a simple struct, basically.
Oh yeah, way beyond. Yeah, it's like a tree of logic rather than a atom of logic. I don't know what you call a struct, but but I mean, like so all of this is a reason. There are actually reasons to put this stuff on chain. Like the stuff that Toby's dealing with in Telegram at the moment is actually a feature. It's not a bug. Being able to permissionlessly say, see right here, these are my subpasses and this is my deployer. You get to make decisions about which versions of the language that you trust. So right now, for a while, we've been working with a version of the language that doesn't have decimal numbers in it at all. And it's had some volume through it. It's been around for a while. It's clunkier to use, but it's got more of that Lindy. Lindy is like, if you don't know it, it's like the usage multiplied by the time, right?
It's like
the longer something's in use for a longer period of time, there's been more chance for things to go wrong. So it's just like a way to measure.
It's 10 days without an accident.
Exactly. Yeah. Decimals is like not that many days without an accident, right? Because it's newer. Like it was only made like a little while ago. So if you want that, you can jump onto the new one. And if you want to keep going with the old one, you can keep going with the old one. And we have the same interface, which has like the same very broad, high level structure around how things go in, but it's quite loose. And then in that, people get the freedom to make their own decisions about which versions of things that they actually want to use when they're deploying. And the same order book supports all of them as long as they have the same interface, which is really cool. So because of that, we don't have any admin keys in Raindex. We never do like upgradable smart contracts. Like I never go in and with like a key and say, oh, order book is now using the version of Rainlang that supports decimals, and then pull everybody over to that, and then they're all forced to use that, right? So because I can't do that, there's no admin keys, I can't rug liquidity.
And then we made the app with no hard code or anything, which means when people who don't know get the app for the first time, they're like, they don't know where to start, because
this can be fixed. That can be fixed. That's not a fundamental problem. That just means that we haven't like added some default settings that pull in some information, like the chain list thing.
Right. Browsers ask what does the future look like? What sort of dApps can be built? So it's a profitable setup infra for solvers. I mean, we just talked about a whole. I mean, you came up with it with us this morning, which is like there's a whole app.
Yeah, you tell us.
Yeah, there's a whole dApp you could build on top of this, where you could build an options protocol. Literally, you could build an options marketplace on top of Raindex, and you've already got the prototype for it. Literally, you put a few lines into Rainlang, and now you've got an options marketplace. But I mean, I think it goes pretty endless. I mean, also we just then we talked about the setup for using Raindex is not that easy. I mean, I think it's pretty obvious someone is going to build a super friendly GUI that has CalSwap style, has like 5 order types of the most popular orders, and people will just plug in the parameters and it'll use Raindex and Rainlang. And the person who makes that app, when they want to create new order types, they'll just have to write new Rainlang, and they won't have to write any Solidity at all to make a trading thing. So that seems pretty obvious to me that someone should do that. I mean, you could even build something like, I think someone could build something on Farcaster, where they build a Farcaster, because Farcaster has a wallet, and you can sign transactions with it. So someone could build a Farcaster interface trading thing where you like that again has like a bunch of pre-made order types. So you can do like DCAs or Dutch auctions or whatever people want to do. And you can interact with
if you make something cool enough, if you actually make something cool enough, we'll add it to the bar on the left. There's lots of space there, right? Like we're going to add in at some point we're going to add in a little icon for leverage trading.
Yeah.
So you can build an options protocol, and then we'll add in a little icon for options.
Yeah. Or build.
If it's solid enough.
Honestly, I think the sky's the limit. What we built is completely unopinionated. I mean, in terms of Raindex,
you could do insurance if you can somehow verify whether something did or didn't happen. You could sell insurance policies. Why not? Like basically any financial thing that's based on like conditions and inputs and outputs, you could theoretically wire up.
Yeah, I mean, I think what's cool is the idea that you could have this one, like, you have this one language, and then you have this one protocol, I guess you would call it, this interaction between the language and an on-chain order book, or like a place, like it's basically a bulletin board of all the orders. And there's a standard interface. So no matter what you write in the Rainlang, at the end of the day, the interface for calling any particular Rainlang to make a trade is always the same. And so basically people could build all these different things on top of it. And as a solver, you would get the order flow from all these different apps. So you'd have
totally. Yeah. So it's like 100 products, but a shared solver pool for all of them.
Yeah, exactly. I think that's maybe what Brad's
10 would be amazing.
I think maybe that's what Brad's getting at here. So yeah, but I mean, it's literally just like someone's going to realize at some point what they can build and how easily they can build it. They can just like throw some branding together and build an app on top of this. And
you know what's funny is that's where we started actually. Like Josh was making apps. And they had Rainlang underneath them, and then we would show them to people, and then all they would see was like a basic app, and they would be like, so what? You built like a basic app? And then we'd have to say to them like, yeah, but there's like a whole language underneath it. And then they were like,
cool.
Okay. Like, so that was actually the easy bit, and we did that like a year ago, 2 years ago, just like building widgets on top of this. Is really straightforward. And so we flipped our strategy around, knowing that it was less approachable for people because it wasn't just like a widgety interface, because what we want the relationship with people and Rain to be is of an ecosystem where you can pull up the Raindex and you can do whatever you want. Like it was cool in Telegram, like just planning out a crazy options protocol, and like it wasn't difficult. Like we were just chatting, and there were some rough edges, but we were just chatting, and it was like, cool, now we know how to do it. And having that level of freedom, but then people can build the widgety stuff on top if they want to, but it's hard to show people how to go back the other direction. So
yeah, I think that's the thing. You can't go from no one sees what's under the hood, but we actually did, and it wasn't about, we don't want to convince, also it's not really about convincing people, it's about convincing people how good your thing is. Feels like that's what happens a lot in crypto, and people like saying, look how good this thing is, and then people ape in on some token, but they never actually use the thing. Whereas we're literally saying we don't have a token, and we're not trying to convince you that it's good. We actually want to create something that is good and actually leads to more things being built that are useful. I can actually move the whole industry forward.
Oh yeah, I want to be using Rain for like all my personal finances at some point, just for the rest of my life, and then other people can do the same. That'd be great.
Yep. Yeah. Well, I mean, that's the other thing that someone could build with this would be like a more of a portfolio management tool. I mean, this already is a portfolio management tool, but like something where you could, as a user, I could like pick a bunch of tokens and then I could create a portfolio balancing order. So I could just put in like the percentages of things that I want into like a nice interface. So basically I could design my own index fund, and then I could then this interface would help me put that order together and then enable me to like see my portfolio and readjust it, or try different baskets of tokens or whatever. Oh, that's interesting. Rebalancing as a solver. You mean like because as a solver you've got your own treasure, like your own liquidity you're using for filling orders, and you might end up with like loads of some token and you need to offload that. Like if you're doing, I don't know, you end up with some like random meme coin and you need to like get out of that into something, swap out of that back into ETH or whatever. Yeah, that's cool. I mean, you could use, I mean, then if you put as a solver, if you put up an order that was a rebalancing order and you deposited the tokens that you got back into Raindex, then you'd let other solvers rebalance your solving portfolio for you.
Why not?
Yeah, it's kind of interesting. The other thing that you can't do right now on that note is that you can't, I guess you can with multi-call, right? So I could put up, as a solver, I could have my liquidity in vaults,
mm-hmm.
and then I could, rather than take an order directly, I could put up a counterparty order to another order and then clear it in one transaction if I wanted to use the balances in my vaults.
Oh yeah, like using clear.
Well, I'm just saying, like in this case, if you were in a rebalancing, the solver would have to be depositing into Raindex. When they actually want to go use that to solve, they have to withdraw it again.
I wonder what would happen if you, I mean, I haven't done this, I'm just shooting from the hip here, but I wonder what would happen if you stuck a vault up, put a bunch of tokens in it, and then the only logic was that you're the only one who's allowed to trade against it. And you had an IO ratio of 0, and then you just cleared against it, and it would always clear if you were the clearer against any other strategy. So you would basically just be taking whatever the other strategy was, but you set the bounty vault as the vault the tokens are coming out of, so they would just loop back on themselves.
Yeah, I see. Yeah. So if there's anything extra goes into it, it just comes back into your vault.
Yeah.
Barrett was saying, interesting thing about Vault is you can open this up to public and give interest as well. Liquidity issue would be solved for solvers. I mean, the liquidity issue is, in terms of Raindex, it's already solved for solvers because you can borrow the other side. So if I put up an order and I want to sell some meme coin, some random ass meme coin for USD, and you as a solver see a profitable arb, like you see, the price that Josh wants for his random meme coin, I can go get more than he wants on this DEX. Like he wants this much USD, I can go actually get more USD than that. Then you can just borrow the tokens from the order book, take them to the DEX, make the swap, get the USD, give me what I asked for, and then keep the difference because you found a better price. And you can do that in one transaction. You don't actually need, to have the meme coin and then go make the trade first.
Yeah, we implement flash swaps, which is what Uni implements, where when you take an order first, the order sends all the output, actually, and then it waits to receive the input back, and then checks and then reverts if you don't. So it's a flash swap. The DEX also implements the standard flash loan interface. If you just want to borrow capital from the DEX without actually doing a take order or something, you can just borrow it, do whatever, and then bring it back.
Oh, really?
Yeah, it's all flash loanable.
Oh, crazy. So all the liquidity on, you work the same as Uni. Yeah, exactly. It's the same interface as a Uni flash loan. So you
Yeah,
can,
there's actually an ERC standard for flash loans, so we're just using that.
yeah, so you can borrow any of the capital on Raindex. Anything anyone has in a vault, you can already borrow it as long as you return it by the end of the transaction.
Mm.
Is there any? Does uni ever ask for interest, or is the interest part of the standard?
Uni, no. The flash loan can charge a fee, but it's a fee. It's just like a once-off fee for the loan. It's not an interest thing.
Interesting.
Yeah. So we don't charge any fees. We don't charge any interest. If you wanted to do that type of thing, I think it would live in this governance wrapper level, basically. So how would you do that? If it was in Rainlang, you would say, okay, this amount has been deposited. We've been tracking the deposits as people have been depositing, and then what you're charging is accounted for in the internal ledger somehow. So when people do withdrawals, it would be the fees would be subtracted from that, and then somehow set aside, and then someone else can take that out, right? So it would be like at the governance level, you would split up everything, right?
Yeah.
So if people deposited like $100,000 through the governance contract, and then they left it there for a year, and the interest that you were charging on it was like 5%, then on the way out, $5,000 would get set aside to the governance wrapper, and you'd only be able to take out 95,000. So it would like run through the wrapper somehow, rather than Raindex doing it itself. So I'm in the way that I'm designing Raindex, I'm really trying to make it stable, which is a strange thing to say while we're like in the midst of changing it. But I'm trying to make it stable. So the less that it does, the better, actually. So the goal is to make it friendly to writing wrappers, and those wrappers can be a standalone contract that has its own Rainlang that handles money. They're basically like money handlers, like divvying things up, controlling when things can be deposited and withdrawn, like all of those kinds of things. They can be in between Raindex and actual end users, and themselves can be controlled through Rainlang. And we can change those really easily and often, and make a dozen of them, use them for a bit, throw them away, without ever actually changing the underlying DEX contract.
Yeah.
Whereas if we wanted to add a bunch of logic for pooling, withdrawal, deposit locks, whatever it was, every time we had a new idea, we'd have to go and update the DEX again, which would be it'd be possible, but it'd be really annoying, because then you need new infrastructure. The solvers need to know that there's a new version of the DEX. You need a new index. You need like new subgraphs. You need like people need to be told, okay, everyone go and update your settings, etc., etc. So the idea is to make the DEX as stable as possible, and then make a more chaotic, throwaway, configurable, disposable layer on top of that handles stuff like that.
Yeah. Brath asked, how will you guys make money out of this if everything's open source and no fee? Well, this is an opportunity for us to spruik our market making services. If you are a project that has, or you're anyone that wants to do on-chain market making, we will help you write a bespoke strategy for your exact needs and deploy it with Raindex and monitor it, etc. Yeah, so that's our revenue stream at the moment. So if you are,
and we are building stuff as well at the protocol level too, but it's in that messy layer.
we've got ideas, yeah. We've got different ideas for things we can build on top, but the base layer, Raindex itself, and of course Rainlang, it's Rainlang as the language, will never have any fees. Like, that's super important, actually. It's important that there's no reason to fork Raindex or Rainlang. You're much better off joining forces with us. And if you want to do fee stuff, build it on top, and everyone benefits from contributing equally to the underlying layer, then going and making a fork.
Yeah, the way I look at it is like look at Liquidity. Liquidity is like a immutable contract, and then people build lots of different front ends for it, and they can get commissions for running a cool front end that people like to use. Versus like Uniswap, which there was just one Uniswap, and then pretty much the day that they introduced fees, everybody started wanting to fork Uniswap with less fees or different fees or vampire attack or like this. It puts like a meta game on the protocol that ultimately turns things from being cooperative into competitive.
I mean, I guess the other thing is people just want a justification for a token. So if I just make a Uniswap front end, like how do I justify my governance token? I need to have we need to be doing stuff. We need to have committees and proposals and stuff, and then we can have a token. People can buy the token, and then we can sell the token.
Yeah, it becomes like skeuomorphic shares, right? It's like, oh, we have this ledger and you get voting rights for the governance and you also get dividends, but it's definitely not just unregistered securities that are basically shares.
Yeah, which we have currently, to be clear, we have no plans for a token. It will never be a rate.
No plans for a token. So current state is like market making because it just makes total sense. It's really like, well, we use everything that we already have, and then we try to market make your token. And if we run into an issue, we improve the DEX and then try again. And then we can do it. And then everybody's happy. Future state is this more messy layer, making protocols that can take fees. And we already have like a concrete one that we're working towards. And that's basically has some pooling in it, has some leverage in it, has some risk reward dynamics in it, and then if everybody's happy, we can take like 1% or something. Another thing that might happen, although I really don't know if it will or not, it really depends on how things pan out, is if people really get into back testing, simulating, forward testing, like stuff that might potentially be infrastructure heavy other than solving, like in the interface. So say you right now it just does like a random simulation, but say you wanted to see how your strategy would have performed over the last 6 months or a year on Arbitrum, and you want to simulate every single block, and it has a 260 millisecond block time, and you need to hit an RPC for every one of those blocks to simulate it, you're not going to do that on your laptop, you know, right?
Oh, and yeah, you might not have a node, access to a node at all, or not one that you can do that many requests to.
Yeah, you might be able to do like a short period of time, or you might be able to do like quite a sparse simulation and say, I'll just simulate it once a day for the last year. That's only 350-ish. But if you want to go like really fine grained, so I could see if there's like a need, if people feel like there's a need to go really in depth with like a lot of this data stuff, we could potentially just set up nodes and things that run simulations and stuff, and you'd basically send the .rain file, and then we would just run the .rain file, and then we would send the data back, and we'd be like, okay, here's all your data, and then it would plot the charts out and stuff on your level.
Yeah, so because you might want to backtest with a strategy, and you might have some you might have like 3 parameters you want to tweak, and each of those parameters has like a range of 50 different values or whatever. So suddenly you have like 50 times 50 times 50 options, and you want to backtest over the past year of blocks, like to find the optimum version of your strategy. Like that's going to be a lot. That's a lot of RPC calls. So yeah, so basically revenue idea is do infra stuff for people that they're not able to be able to do for themselves if they get to those like advanced levels. And if they're doing something advanced, then they probably wouldn't mind paying it like a little bit to us to do that, considering people make us stuff all the time.
Yeah, it's like TradingView. Like if you go to TradingView, they have tiers, and you go up to certain tiers and you get all this like crazy back testing, and they'll like do all this stuff for you. But there's also just the default app that you can just download and use for free.
Yeah, and we're not basically, importantly, we're not trying to stop anyone from developing their own back testing.
Definitely not. To be clear, all of this would all be done in a way that you could do it yourself, and I'm just very confident. Most people are not going to do that. They're not going to be like, yeah, I'm going to set up my own Arbitrum node, because if you've seen the requirements for setting up an Arbitrum node, you know that you need quite a bit.
But we are doing backtesting. In fact, we're talking about it this morning. It's not actually that difficult to implement in a basic way. So we may have backtesting.
Really simple, yeah.
We might be showing backtesting on the next live stream. That'd be pretty cool.
That'd be awesome. But now that you said that, it's definitely not going to happen.
And in terms of selling strategies, yeah, I mean, with H2O, our market making business, we are selling strategies. We have a B2B operation where we're selling strategy writing to people, strategy writing and configuring to people. In terms of building a marketplace in the app,
that'd be cool.
Yeah, there's no reason we couldn't eventually build a marketplace. Like we have a whole list of ideas for P2P features within the app itself. Like, especially like there's stuff like community strats and forking, like the way June works. Like you go to June, I can show you a strat, you can open it up, and then I can make a June chart, send it to you. You can see the query I made for the June chart, and then you can fork it and tweak it to your own needs or whatever. There's all that stuff, and then there's also like business stuff for businesses. Like you may have a team, if you like work on I don't know, whatever, you've got a team of people that are working on stuff. You may want to privately share strats to each other, and there's a whole bunch of features we can build into the app for that as well. If we do that, it'll be P2P. It won't have servers. So we won't be like a regular SaaS thing where we're keeping a database of all the user accounts and everything. We're never going to have that. If we built these features, it would be literally P2P, like BitTorrent for strategies.
Yeah. I mean, that would be awesome, right? Like that's
people are pumped about backtesting, by the
way. I think backtesting is going to be like the biggest ratio of effort to new feature ever of all time.
Yeah, I mean,
I don't want to like, but
I think that's true. I was going to say leverage, but leverage is going to be a lot of work. So the ratio.
It's going to be a lot of work. The thing with backtesting is like, it's literally just the same thing we already have, where we just generate random numbers, and instead of generating random numbers, we'll just go read the actual numbers
and do it on a range of blocks. Yeah, I'm pretty excited. It's going to be really cool. It's going to be pretty awesome to be able to like, it's going to be weird to like be able to fork back and get Uniswap prices and build charts in Raindex, like build historical charts in Raindex.
It's going to be great. The thing is, we already did this like in Istanbul, remember? We were down in that bunker on like the 5th floor or whatever it was at DevConnect. And we were creating charts by looping over the blocks and doing the same thing. It's just that we were doing it manually in like Excel and with like the script that we ran, and then we were like putting it together, and it would take like, I don't know, God knows how long. It was like hours to put together like one of these things. But it'll all just be the same thing, but just like run natively in the app, and it will take like 20 seconds instead of 6 hours or whatever it was.
By the way, I just realized, could you use what we have now if someone wanted to look at like the price impact of certain trade sizes on their pool, like especially if they have a pool with concentrated liquidity? You could do that, right? Because you could fuzz the input to a UniV3 word, and then look at the the ratio of the law. Anyway, that's just a thought.
Yeah. The uni words have slippage and fees incorporated into them. So when you ask for the exact output, and then if you fuzz the input, it'll give you it'll give you all the different outputs, and then what you would need to do is divide the input by the output, and then it would give you all the different prices for all of those different fuzzed inputs, and then you could plot the input against the input over the output, and then it would give you like a slippage chart. So you could do that. That's
pretty cool. I also realized that when we do back testing, you'll be able to test the actual size of your trades, not just the price data. Like if you get price data, if you go into like CoinGecko, whatever, you look at price data, you're getting like an aggregate spot basically. Whereas with this, you could actually look at, well, what if I'd wanted to trade $1,000 of this meme coin? Would I have actually got that price, or would I have got a much worse price? Because in some of the cases, it would be a lot worse.
Like, what if I wanted to buy, say, $1,000 of Frax on Polygon, and then casually rotate it into any other stablecoin at any point in the next 2 months?
Yeah, that happened to us. Brad says, is it too hard to write an architecture diagram in the docs? Which architecture for what? Because I thought we do have like a basic one, but maybe there's something else that you're referring to. Because core concepts architecture. Okay. Yeah, this the core concepts stuff is old. Yeah, that's interesting. The rain stack. Yeah, that could probably use a diagram. You're right. So much to do. Of course, these docs themselves are open source, so PR's welcome if anyone.
Isn't there also a documentation bounty right now, like competition?
We have a comp. Well, the comp closes in a few hours for someone to write some technical writing about strats. But yeah, even if you're not competing in that, if you see stuff in the docs and you're like, that could be better, feel free to put up a PR, because we could use the help. This is an open source project after all.
It is.
We're building a thing, and then along the way, we're trying to figure out ways that we can use it to build businesses on top. But
I'm hoping that someone builds a business on it, and then they feel like they should contribute to it as well. That'd be nice.
Yeah, I think someone will eventually. I think it's probably there's some catalyst point where we've done like all the groundwork, and there's enough examples out there, and the kinks are ironed out of the language, and someone would be like, oh, I can literally just like throw together a options marketplace at hackathon, and then we'll be away.
Yeah, it's really just like all the details that you tell me are boring, and I guess they are boring, like negative numbers, good precision when you're multiplying really big numbers with really small numbers, being able to do like the one we talked about today, we'd never really thought about before, but it makes sense that you could like charge the state changes, like the governance wrappers on top. Like you do enough of these like little things, and like the overall result is like at some point it's like, oh, this is actually like a serious product development platform as much as it is a trading platform.
There's I thought how many contributors there are. There's 9. I mean, if you look at the order book repo, there's 9 total historically, but we're like 5 people. So
yeah, I know who wrote all the Solidity.
we're more than 5. I guess we're like 7 people right now, but we're doing a lot of stuff. So yeah, there's a lot going on at the same time. Anyway, we are over an hour, so we should wrap it up for today. Thanks.
So maybe next time we will go over, because we were going to talk about the charting, if you want to do like rebinding the call stuff, so you could do like mocking out things for charting. So maybe we'll do that in the next stream, which is a week away. So maybe we can also just put some stuff in the Telegram in the meantime, so that anyone in the Telegram can get that information and do what they need to do in the meantime, and then we can go over again in the live stream next week. Because I think we just ended up talking about solving and stuff, which is also a good topic today, but we definitely should have like a bit of a session on that at some point.
Yeah, well, maybe we'll be talking about backtesting at the same time. You're dubious. You never know. It could happen. A miracle could happen.
I just know that this is software development, and as soon as you set a date, you immediately make that date invalid.
Yeah, true.
It's just the gods of software development. Something will happen, and then this won't happen because you've said it.
Brad said, have you ever tested how long it would actually take to actually do this traditionally versus using Raindex?
Doing what?
I guess you mean like doing orders like this? Like writing trading strategies? I mean,
on-chain or off-chain?
Well, we know what on-chain kind of looks like because, well, the thing is, no one does it, right? No one writes on-chain strategies in Solidity. No one's doing that. Uniswap 4 hooks are pointing at a need for more configurability around how AMMs work, but we just took it to its logical conclusion where we were like, rather than creating a way for devs to create more options for users, just make more users devs.
Yeah, pretty much. I mean, you could break that question into like a few parts. Like, the first thing you need is a DEX that supports it. So let's assume you have that. You have a DEX that is exactly the same as Raindex, or close enough for the sake of argument, and then you want to write the same thing in Solidity. So what have you got on the screen? You have an FTSO current price USD. Josh, do you have the code that's involved in getting the FTSO current price in USD in Solidity? That one word.
We can pull it up.
Let's pull it up.
One second. All right, so it's in concrete.
In the op, probably. Yeah, FTSO current price USD. That one. This is the Solidity behind that one word.
So when you run it, okay, so you run it. I'm gonna try to understand it. So I get the registry, right? Okay, because the FTSOs don't have a fixed location. There's a registry that says where they are. So first I have to get the registry. Then I have to Then I have to find Then I have to find the specific FTSO I'm looking for. Okay. So if it's active or not. Then I get the price finalization type, which we can't get from the current price otherwise. I don't even know what this is, so I get a bunch of stuff from it about its last price epoch finalization type. So this comes from the FTSO itself.
Yeah, that's from the FTSO.
Okay, and then I get
because
some stuff.
The FTSO is based on oracles, so the FTSO can be in like certain state. It could be paused with the active thing, or if the oracles have not fully reached a quorum on exactly what the current or what the price that you're querying is, then there's like other states that it can be in. So the good states is like the weighted medium or like the trusted addresses, but then there's like other states where, for example, one of them is like, we actually didn't come up with a price now, we actually copied the last price and we actually copied it across. So we don't want that.
So we're protecting, so basically we're trying to protect users against bad prices. So we're saying unless it's of these two types of these two finalization types, then we won't let you use the FTSO at all.
Yeah, exactly. It actually needs to be, because we have a staleness parameter in the word, so we actually have to have reason to believe that the price that they're getting is actually from the time period that they're getting it. It's not just some old price that hasn't like reached quorum for the new ones.
Okay, then we need the decimals. Okay, so we get the decimals from the price so we can normalize. Then we do a check just because we can. Then we handle stale prices, and then we normalize the prices so that you can use it easily with other numbers without having to worry about things being at different scales. Yeah, I mean, that's definitely a lot harder than writing a single word. I don't know if that gives you an indication, Brad, of like what's going on under the hood, but
quite a lot of the words are like this. Like, even just like basic math, there's still like whole math libraries in Solidity underneath.
Yeah, I mean, this is execution abstraction, correct? Yeah. Well, we saw a guy from Paradigm, one of the tech guys from Paradigm, do a talk in a Dev Connect in Istanbul, and he was talking about like improvements to EVM, and he was talking about I think he called them like super opcodes or ahead of time compilation. So the idea that the EVM itself would have additional opcodes, which would be a bundle of opcodes under the hood. So you'd be able to use an opcode, and then it would actually do a bunch of other stuff. And we went up to him after his talk, and we're like, we've already built this, and we've made it. It doesn't need to be built into the EVM. It's just a smart contract. So yeah, it is execution abstraction. That's the whole idea. And it's when you write Rainlang, it doesn't compile this. Like, it's not trying to do all this and compile it into a new contract for you. It's already been compiled. This is already compiled. This already lives on chain, and it lives on chain immutably, so it never changes. So every time you write a word in your Rainlang, you point at this compiled code that may have lived on chain for years and runs exactly the same every time. And you don't pay to deploy anything new. We already paid, or whoever wrote and deployed this already paid for the storage of this logic, and you're just referencing it in your Rainlang. Anyway, now we're 20 minutes over. It's a long one.
Yeah. All right, let's wrap it up. We can do it again next week.
Yeah. All right. See you, everyone.
Yeah.
Bye.